Edwin Powell Hubble was an American astronomer. While observing distant galaxies in the 1920s, Hubble discovered something that changed the course of astronomy. He found that the light coming from two galaxies located near and far away from Earth isn't the same. The light coming from a galaxy farther away from Earth is more shifted towards the red spectrum than a nearer one. In simple words, the wavelength of light is increasing. It is being stretched before it reaches our planet. This phenomenon is known as redshift. This discovery made him think that something must be happening between Earth and those galaxies, causing the redshift effect. So, what did he do? He observed more galaxies and, surprisingly, noticed the same phenomenon with every galaxy he pointed his telescope towards. He knew that the space between Earth and those galaxies was increasing. In other words, he discovered that the universe was expanding. Hubble published his findings in a paper in 1929. Just 2 years later, a Catholic priest and physicist, Georges Lemaitre, coined the idea of the Big Bang. His reasoning was simple. If, at this point in time, the universe is expanding, when we go back in time, the universe must contract. And if you contract the universe enough, it becomes a point of infinite potential. We like to call it a point of singularity. The energy required to give birth to an entire universe is contained within this point of singularity. One day, a species born from the same energy released from the singularity will write about it, because this point of infinite energy isn't stable at all. When the singularity acquired enough randomness, the Big Bang explosion occurred. This explosion gave birth to both space and time. Within a fraction of time, Big Bang created all the energy that will fuel billions of galaxies and give birth to trillions of stars. Things get hot when there's an explosion. For comparison, the temperature at the core of our Sun, where all the fusion takes place, is 15 million degrees Celsius. When the Big Bang explosion occurred, the immediate temperature was over 1,000 trillion degrees Celsius, hotter than anything we've ever seen in the universe. Big Bang theory has been wildly successful so far, but no theory is perfect. There are things that even this model can't explain. The Big Bang model states that before Big Bang, the universe was infinitely dense, stuffed into a point we call a singularity. So, where did the singularity come from? Did it come from an event that we don't know yet? Or has it always existed? We've come to the conclusion of singularity from the fact that our universe is expanding today. But how can something, the singularity, come out of nothing? We can't be sure if singularity is the only reasonable explanation for our universe's birth. But let's suppose our universe did come from a singularity that came out of nowhere. Why did it bang? If the singularity has existed for eternity, what forces acted upon it that caused it to become unstable and suddenly explode? Was that force internal? Did the singularity become unstable from inside? Or were there some external forces? There are foundations upon which every scientific theory stands. When it comes to the Big Bang model, we have multiple shreds of evidence that it really happened. Big Bang theory states that lighter elements, such as hydrogen and helium, were formed in large quantities after the explosion. It was easy for single or double protons and neutrons to bump into each other, and sometimes even stick together, forming the nucleus of an atom. Today, when we observe the universe, we find that approximately 73% of the total mass of the universe is hydrogen, and another 25% is helium. Almost all the stars in the universe, including our own Sun, are made up of hydrogen and helium. Whenever we talk about the Big Bang Theory, it's essential to talk about the cosmic microwave background, because it confirms the essence of this theory. Arno Penzias and Robert Wilson are two American astronomers. In the early 1960s, they set out to map radio signals from the space between galaxies. But no matter which direction they pointed their telescope, there was a constant background noise interrupting their observation. At the same time, physicist Robert Dicke theorized that if our universe was super hot at its beginning, it must have created a lot of radiation. The same radiation would still exist throughout the universe. He visited Penzias and Wilson at Bell Labs and confirmed their findings. The mysterious signal was the cosmic microwave background radiation left over from the Big Bang. Penzias and Wilson won the 1978 Nobel Prize in Physics for this discovery. With our modern telescopes, astronomers have mapped out the entire observable universe and created a map of the CMB radiation, a proof of how it all came into existence.